On a Tuesday morning in 2018, inside a manufacturing plant in Wilmington, Delaware, a worker reached toward a 125-ton punch press to clear a jammed part. His foot was still on the pedal. The ram dropped. In less than a quarter of a second, 3 fingers were gone. He never saw it coming. There was no explosion, no fire, no warning alarm. Just the ordinary sound of metal meeting metal, and a man's hand permanently changed. The machine did exactly what it was designed to do. It punched, it pressed, it did not wait. This is the story of the punch press, a machine so fast that human reflexes cannot compete. For more than a century, these devices have powered American manufacturing, stamping out the parts that build cars, appliances, and aircraft. They are precise, reliable, and relentlessly efficient. They are also responsible for one of the longest-running industrial injury epidemics in American history. The numbers are staggering and largely forgotten. According to federal data, approximately half of all injuries involving mechanical power presses result in amputation. Fingers, hands, and forearms have been fed to these machines by the thousands, year after year, decade after decade, and the toll keeps climbing. This is how punch presses became the finger takers. Factories did not adopt punch presses because they wanted to hurt anyone. They adopted them because nothing else could do the job as fast. A punch press is a machine built for one purpose: to force a hardened steel tool through metal with enough power to shear, shape, or punch holes in fractions of a second. The mechanism is deceptively simple. An electric motor spins a heavy flywheel, storing kinetic energy like a battery made of steel. When the operator triggers the stroke, a clutch engages. The flywheel's rotation transfers through a crankshaft, converting spin into vertical force. The ram drops, metal yields, the cycle repeats. This technology traces its roots to 15th century screw presses, originally used for minting coins. But the Industrial Revolution transformed it into something far more powerful. By the 20th century, punch presses had become the backbone of American manufacturing. Automotive plants, appliance factories, aircraft suppliers, electronics assemblers, anywhere metal parts needed to be stamped in high volume, punch presses did the work. I need to pause real quick. If these industrial history deep dives are something you enjoy, I would be grateful if you could subscribe and let me know in the comments below which workplace hazards I should investigate next. Now, back to the story. The scale of deployment was enormous. By 1980, federal surveys counted more than 150,000 workers operating mechanical power presses in the United States alone. These machines ranged from modest 15-ton units to industrial giants exceeding 1,200 tons of pressing force. Some ran at 300 strokes per minute. That is 5 punches every single second, hour after hour, shift after shift. Why did manufacturers love them? Precision and speed. One press could stamp out hundreds of identical parts per hour, with tolerances measured in thousandths of an inch. The economics were irresistible. Faster production meant lower costs. Lower costs meant higher margins. The machines paid for themselves quickly, and factories ordered more. Factory owners saw precision and profit. What they did not see was the trap being built into every stroke. Because the same speed that made punch presses valuable also made them unforgiving. The ram did not pause. It did not hesitate. It did not care. And as we will soon find out, the human hand was never meant to compete with machines measured in milliseconds. Here is a number that should disturb you. According to data compiled by the Occupational Safety and Health Administration, approximately 49% of all injuries involving mechanical power presses result in amputation. Not lacerations, not fractures, amputation. Nearly half of everyone hurt by these machines lost part of their body permanently. The annual toll was relentless. Bureau of Labor Statistics data from the 1980s indicated that between 1,600 and 2,000 amputations occurred among power press operators every single year. That is not a one-time disaster. That is an ongoing epidemic, year after year, decade after decade, stretching back further than most people realize. Let me put that in perspective. Every working day, somewhere in America, multiple workers lost fingers to punch presses. This was happening through the 1980s. It continued through the 1990s. It persisted into the 2000s. It is still happening today. The machines kept running. The count kept climbing. Could you imagine going to work each morning knowing that 1 in 2 injuries on your machine would end with something permanently missing from your body? That was the reality for punch press operators across this country. Over 50 years of documented injuries, the cumulative toll is staggering. More than 100,000 American workers maimed. Fingers, hands, forearms, fed to these machines in factories from coast to coast, every state, every sector that worked with metal. Automotive suppliers in Michigan, appliance plants in Ohio, electronics assemblers in California, sheet metal shops in Texas. The geography did not matter. The outcome was the same. And here is something that makes this even harder to accept. The workers most likely to be injured were young men. Research showed that operators under 31 years old faced the highest risk of amputation. Studies conducted by the National Institute for Occupational Safety and Health found that 79% of young male operators moved their hands faster than the safety calculations assumed possible. They were quicker than the standards accounted for, and that speed became a liability. The regulations existed, training programs existed, guards and safety devices existed. None of it stopped the bleeding. The injuries continued at rates that would have shut down any other product, any other industry, any other machine. But punch presses were too valuable. Production could not stop. So the hands kept going in and the pieces kept coming out. The industry knew the numbers. The government tracked the numbers. Insurance companies calculated the numbers into their premiums. But changing those numbers meant understanding something fundamental about how these machines actually worked and why human reaction time would never be fast enough to matter. That understanding came slowly. For tens of thousands of workers, it came far too late. The danger was never hidden. It was built into the physics. A punch press ram does not descend slowly. It drops in milliseconds. The entire stroke, from top dead center down through the material and back up again, happens faster than the human nervous system can process a threat and respond. Let me tell you exactly how fast we are talking. High-speed mechanical presses complete dozens of strokes per minute. Some machines cycle 300 times in 60 seconds. That is 5 complete punches every single second. The ram is down and back before you could snap your fingers. Now consider the human side of that equation. The average person needs between 150 and 250 milliseconds just to begin reacting to something unexpected. That is only the start. Once your brain registers danger, additional time is required to send signals to your muscles, initiate movement, and physically pull your hand clear. The total withdrawal time is measured in hundreds of milliseconds. Here is the problem. A punch press stroke can be complete in less time than a single blink of your eye. Blinking takes roughly 300 to 400 milliseconds. The RAM can finish its work before your eyelids close and open again. OSHA recognized this mismatch. Safety calculations were built around a hand speed constant of 63 inches per second, about 1.6 meters per second. That was how fast regulators assumed a worker could withdraw their hand from danger. But research conducted by the National Institute for Occupational Safety and Health revealed something troubling. Young male workers, the primary operators of these machines, frequently moved faster than that constant assumed. 79% exceeded it. Their quickness was supposed to help them. Instead, it gave them false confidence. Why does this matter? Because no amount of attention, training, or experience can overcome physics. If the machine completes its stroke faster than you can react and withdraw, being alert is not enough. Being careful is not enough. The math simply does not work in your favor. And yet factories pushed for faster machines. Faster meant more parts per hour. More parts meant more profit. Production quotas and piecework pay structures rewarded speed, not caution. Workers who slowed down earned less. Workers who kept pace with the machine risked everything. The economic incentives pointed directly toward danger. The point of operation, that narrow gap between punch and die where hands had to go to load and unload parts, became a guillotine cycling dozens of times per minute. Workers lived inside that rhythm every shift. The speed was dangerous enough on its own, but speed alone did not explain why injuries kept happening to trained operators who understood the risks. The answer was hiding in the machine's design, a flaw that turned ordinary human behavior into catastrophic error. Not all punch presses were equally dangerous. The difference came down to a single component that most workers never thought about: the clutch. Older mechanical presses used what engineers called a full revolution clutch. Once the operator triggered a stroke, the machine could not be stopped. The RAM had to complete its entire cycle, down through the material and back to the top, before it could halt. The braking mechanism depended on raised keys called dogs that could only engage at one position, top dead center. If your hand was in the die when the cycle started, there was no emergency stop. The machine would finish what it began. Newer designs introduced part revolution clutches with friction brakes similar to those on commercial trucks. These could halt the RAM mid-stroke, but millions of older full revolution presses remained in service for decades. They were paid for. They worked. Nobody wanted to replace them. Then there was the foot pedal. OSHA data from 1975 through 1983 revealed that 62% of mechanical power press injuries involved foot-controlled machines. 62%. That number tells a story. Here is why that matters. The foot pedal created a direct path from a moment's inattention to permanent injury. The operator's hands were in the point of operation, loading a part or clearing a jam. Their foot was near the pedal, ready for the next cycle. One small shift in weight, one reflexive twitch, one bump from a coworker passing behind. The cycle began. The RAM dropped. The hand did not move in time. Some machines had an even worse problem. If the controls malfunctioned, the press could repeat, cycling again and again without additional input. Workers caught in this loop faced multiple strokes before anyone could cut power. Material jams made everything worse. When a part stuck in the die, production stopped. The instinct was to reach in and clear it quickly. Many workers did exactly that without fully disengaging the machine. They trusted their speed. They trusted their luck. They were wrong. Guards existed. OSHA required them. But guards slowed production. Some operations demanded reaching close to the point of operation regardless. Workers disabled guards to meet quotas. Supervisors sometimes ordered guards removed to speed output. The safety equipment sat unused, while hands went back into harm's way. Training was supposed to prevent this, but training was often rushed or inadequate. High turnover meant new operators on dangerous machines with minimal preparation. Language barriers in diverse workforces left some workers unable to read warning signs or understand instructions. The design was flawed. The incentives were misaligned. The safeguards were absent or ignored. By the time federal regulators addressed punch press injuries systematically, the machines had already claimed generations of hands. And what investigators found was a pattern of carnage hiding in plain sight. The case files read like a catalogue of preventable horror, each one documented in clinical language, each one representing a life permanently altered. In 2018, at a manufacturing plant in Wilmington, Delaware, a worker reached toward a punch press to clear shelf dividers that had jammed in the die. His foot remained on the pedal. While his hands were inside the point of operation, the press cycled. The ram delivered its full tonnage onto his fingers. He sustained a crushing injury that resulted in partial amputation of 3 fingers on his right hand. Investigators later learned the light curtain safety device had been positioned too low to provide protection. Co-workers had already reported this to the supervisor. Nothing changed until the blood was on the floor. In Michigan, a 19-year-old male was using both hands to unjam a mechanical press when it engaged unexpectedly. He lost the index, middle, ring, and little fingers of his right hand, amputated at the proximal phalanges. 4 fingers, gone in an instant. He was 19 years old. Could you imagine being 19 and losing 4 fingers before your career even started? Another Michigan case involved a 21-year-old woman whose left hand was crushed in a press. Her index, middle, and ring fingers were unsalvageable. Each was surgically amputated. She was 21. A 30-year-old man had his left hand beneath a press that delivered 1.9 tons of force, nearly 4,000 pounds, onto his fingers. The crushing injuries extended the entire length of 3 digits. Surgical amputation followed. Could you imagine 4,000 pounds coming down on your hand? That is the weight of a small car concentrated on an area smaller than your palm. Perhaps the most disturbing account came from a 46-year-old woman working a hydraulic press that possibly malfunctioned. Her right hand was caught. She sustained amputations through the middle phalanx of 4 fingers. According to the incident report, she was initially unable to remove her hand. She eventually freed it only after. And I need you to understand what this means. The fingers broke off. Could you imagine that? Standing at a machine, trapped, waiting for your own bones to give way so you could pull free. The injuries followed patterns that investigators recognized across decades. Crushing and shearing combined to create devastating trauma. The index and middle fingers were most commonly lost, though multiple-digit amputations were routine. Young workers, insufficient training, disabled guards, foot pedal activation. The same elements appeared in case after case. The National Institute for Occupational Safety and Health identified these patterns as early as 1987 in Current Intelligence Bulletin number 49. They knew. The government documented it. The injuries continued. What happened after the ram lifted? Shock, blood loss, emergency transport, surgeries that often meant amputation revision because crushed tissue could not be saved. Then came phantom pain, the sensation of fingers that no longer existed, cold intolerance that made winters unbearable, psychological trauma that shadowed survivors for years. Many workers fought protracted battles for workers' compensation benefits. Many could never return to their previous jobs. Some could never work again. The punch press did not malfunction when it took their fingers. It functioned exactly as designed. It punched, it pressed, it cycled. The workers' hands were simply in the wrong place at the wrong time. A window measured in milliseconds that human reflexes could never close fast enough. But this was not the end of the damage. The consequences spread far beyond the injured hands and the emergency rooms. And what investigators concluded about preventing these disasters would prove far more difficult than anyone expected. The federal government did not ignore punch press injuries. It tried to regulate them. The problem was that regulation alone could not solve a physics problem. In 1971, OSHA published Standard 29 CFR 1910.217 for mechanical power presses. The regulation was based on industry consensus standards and included requirements for guards, inspections, maintenance records, and specific construction requirements. Employers were told what to do. Many did not do it. Injuries continued at alarming rates. So OSHA established a national emphasis program targeting mechanical power presses in 1997. The program was expanded in 2015. It was updated again in 2019. It was renewed in 2025. That timeline tells you everything. Decades of emphasis programs meant decades of failure to solve the underlying problem. Why did regulations fail to stop the bleeding? The enforcement math was impossible. OSHA had roughly 1,800 inspectors responsible for more than 8 million workplaces across the country. They could not be everywhere. They could not even be most places. Economics made it worse. Guards slowed production. Safety devices cost money to install and maintain. Some employers calculated that occasional fines were cheaper than comprehensive compliance. They weighed the penalties against productivity losses and made a business decision. Workers paid the price. And here is something that frustrated me when I researched this. The workers' compensation system was supposed to help injured operators recover and support their families. In practice, it often failed them. Studies published in medical journals found that the American Medical Association's guidelines for evaluating permanent impairment consistently underestimated the actual disability caused by finger amputations. The formulas did not capture what it meant to lose grip strength, dexterity, or the ability to perform skilled work. Compensation varied wildly by state. Investigative journalists documented that some states paid far less than the national average for identical injuries. A finger lost in Florida was worth less than a finger lost in Illinois. Same injury, different geography, different outcome. Financial settlements closed cases. They did not require safety improvements. An employer could pay compensation, accept a fine, and continue operating the same machines the same way. The next injury was just a matter of time. Individual incidents were investigated as isolated events. Inspectors documented what happened. They issued citations. They moved on. The root causes, flawed designs, production pressure, inadequate training, disabled guards were rarely addressed systematically. Each amputation was treated as a separate problem rather than a symptom of a broken system. Could you imagine losing your fingers, fighting for compensation, and then watching the same machine keep running with minimal changes? That was reality for thousands of workers. For decades, the regulatory approach focused on what happened after injuries occurred. Documentation, compensation, occasional penalties. What was missing was a fundamental rethinking of whether human hands belonged anywhere near the point of operation at all. That rethinking eventually came, but it arrived through technology, not enforcement, and it proved that the solution had been possible all along. The solution was never a mystery. Keep human hands away from the point of operation. Engineers knew this for decades. The technology to achieve it existed. What changed was finally using it. Part revolution clutches with reliable friction brakes replaced the old full revolution designs in many applications. These could stop the ram mid-stroke if something went wrong. That single improvement saved countless fingers. But stopping the machine was only part of the answer. Two-hand controls required operators to keep both hands on buttons located away from the danger zone to initiate each stroke. If either hand left the controls, the press would not cycle. Simple, effective. The hands could not be in two places at once. Then came presence sensing devices, light curtains that projected invisible infrared beams across the point of operation. If anything broke those beams while the press was cycling, the machine stopped immediately. No guard to remove, no procedure to bypass. The light itself became the barrier. One company proved what was possible. Interlake Stamping in Ohio operated presence sensing device initiation systems under an OSHA variance beginning in 1976. These systems would only allow the press to cycle when the sensing field confirmed nothing was in the danger zone. For 26 years, Interlake used this technology. In that entire time, not a single worker was injured while operating in PSDI mode. 26 years, 0 injuries. It is nice to finally see evidence of what worked, is it not? Automated feeding systems went even further. Mechanical arms and conveyor feeds loaded and unloaded parts without any human hand entering the point of operation. The worker monitored the machine. The machine handled the material. The geometry of danger simply disappeared. Modern safety standards codified these advances. Control reliability requirements ensured that if a component failed, the press would not initiate. Brake monitors verified stopping times, met safety calculations. The regulations finally matched the physics. But here is the uncomfortable truth. Older presses remain in service across thousands of facilities today. Small manufacturers lack resources for upgrades. Some employers still disable safety devices to increase speed. OSHA's amputation emphasis program continues because the problem is not fully solved. The finger takers have not all been retired. In factories where old machines still run, where guards come off for production, where quotas matter more than caution, the danger waits. What remains is a choice and a lesson written in the hands of those who came before. The punch press taught American industry a brutal lesson, paid for in fingers, hands, and futures. When the speed of production outpaces the speed of human reaction, the machine will always win. The workers who fed those presses did not fail. The systems that put them there did. Today, light curtains glow in safer factories, and automated feeds handle parts that human hands once loaded. But in plants where old machines still run, where guards are removed for speed, Where training is rushed and quotas are king, the finger takers are still waiting. The only question is whether we remember what they cost. Thanks for tuning in.